Hello, we're Group 8 and our project's on fish buoyancy.
The educational concept of a project involves both natural science and applied physics. The swim bladder is an internal gas-filled organ that controls the amount of gas fish store inside their body, which controls the buoyancy force to balance the weight of the fish and counteract with water pressure. By doing this, they can maintain at their current water depth without wasting energy in swimming. We are going to demonstrate such concept using very simple engineering design.
For the product form design, the team decides to make several fish models to show why fish could float in water and how fish control their buoyancy force to adjust their water level. The appearance of this product will be more cartoon compared to the real fish, such as characters in the movie Finding Nemo, because the team believes such design will attract more attention from the target audience. The shape of the product will not have any sharp edges in order to protect young age users. Considering the final result of a demonstration using this product, the size of the product should be well fit into a 95 quart large storage container. Also, the weight of the fish model is designed to be less than 5 pounds for reasons of equipment limitations and safety factor considerations.
Our fish model works by using a built-in air bladder connected via a hose to a plunger. This plunger acts as an air reservoir so that when it's open, the air bladder is normally empty, causing the fish to sit on the bottom of the tank. As the plunger is pressed in, air is transferred to the bladder, filling it, changing the model's buoyancy, and causing it to float. All an educator has to do in order to use this with students is to simply fill the container with water, drop the fish in, and hand the plungers off to the students. The students can then see hands-on how their actions moving the plunger changes the air bladder's size, changing the model's buoyancy, causing the fish to move up and down.
The manufacturing of the device will require more assembly than outright manufacture, as most parts can be sourced complete. Brass 1/8 inch air fittings will be used with the silicone tubing in order to connect the syringe to the bladder within the fish model. To control bladder air volume, a syringe will be mounted to a wooden control board. An HDP Nalgene bottle will form the body of the fish, within which the bladder will be located. One of the more difficult items to source will be the air bladder, as current internet searches have not yielded a viable, ready-made option. It may be one of the only components that will not be sourced complete but will need to be made by the group. The fish silhouettes will be laser cut from thin acrylic sheets to mimic a variety of real fish species. The only tools needed will be wrenches, drill, and drill bits, as well as epoxy.
During our concept generation process, a couple of other concepts were made to increase our options. Some of our other ideas that were not selected include shark teeth growth and replacement, cephalopod inking mechanism, and the makeup of shark skin, specifically regarding denticles. The shark teeth growth and replacement mechanism model would include a mini conveyor belt that will simulate how a shark's teeth is replaced. The cephalopod inking mechanism would roughly model the function of the bodily process to show students how ink is actually propelled by the animal, which is rare for students to witness up close. And finally, the shark skin makeup was basically the idea of modeling several laser-cut shark skin denticles and simulate how they work underwater, where the concepts of friction and force is applied. After discussion and utilizing decision matrix, the fish buoyancy was chosen due to its ability to utilize measurable outputs based on variable inputs, as well as its simplicity of design, making it easy to manufacture, as well as being highly durable to withstand routine classroom wear and tear.